Hello, and welcome to my report on the Week 7 readings. This week, there was considerably less content than usual due to the exam, however we covered a few topics still. These were path independence, what it means for a pointage to complete a round trip, and some examples. For me, this content was all new. We have covered electric potential in previous weeks, but the idea of path independence was new to me. The first thing which we covered was what it means in terms of electric potential for a point charge to take differing paths from the same start point to the same end point. One of these is that each path could and is likely to have different electric fields. Another, however, is consistent between the two. By integrating the electric field, we end up with a formula which is dependent only on the final and initial locations. This means regardless of the locations the point charge occupies between leaving the start point and reaching the end point, the delta V will remain the same. The second thing which we covered was the case where the start and end points are the same point. This could be due to the particle not moving or moving in a round trip. In this case, we can see from the formula derived before that the terms inside the bracket will cancel to zero, and as such the delta C is also equal to zero. For me, the hardest part of this week's lectures was understanding the reasoning, beyond the mathematics, of why the alternate paths result in the same change in electric potential. After reading the physics book page on path independence of electric potential, I feel I understand this better. In the context of my major, computer science, electric potential is incredibly important. Our ability to store electric potential in the form of capacitors allows us to access the world of modern electronics. Something I'm interested in learning more about is what the next steps in development of capacitor technology are. Thank you very much for listening.